Thyag here?
Thyag.
Yeah, sorry, I didn't see you. Okay. I think many of you know, whether you're affiliated with a university or with industry, that the National Science Foundation plays a remarkable role in terms of course, funding the research that universities do. But because of that, it plays a great role in terms of help shape the vision of research at a really large scale, helps encourage interactions between industry and research and academic research, and as such plays a very important role in all of our lives. And because of that, we're very fortunate to have Thyagarajan Nandagopal here with us. He's a program manager at National Science Foundation, and will tell us about what NSF is thinking about in terms of advanced wireless R&D. Glad to have you.
Right. Good afternoon, everyone. Thanks for inviting me. This has been an exciting event, and I really appreciated everyone having a lot of questions to ask. So I just wanted to start, before I start off, I always, I'm a big fan of Dirty Harry movies, and I always used to wonder, how can these guys just go on a high-speed car chase, cut across the middle of San Francisco, when traffic is flowing, pew, the car goes through, nobody gets accidents. Now I know, they have automated cars even back then. The humans were driving, automated cars decided to stop. These guys could just go on with their car chases. So yeah, so that's an exciting future for those who decide not to adopt the early technology yet. So we can still race around a little bit. So, okay, so good. So I just, I'm not, I normally go out representing NSF, but I also take it upon as my obligation to inform people that there's much more stuff happening in the federal government that directly affects the average researcher on the ground. And many of you may not be aware of it, so I usually go on a little blurb on what other initiatives are as well. So let me just go briefly on that before I get into NSF specific things. So there are many federal agencies that are that have some kind of a tie-in to FCC, into the wireless and spectrum-related work. I mean, keeping in the theme of this workshop, I did not put DOT. It was my omission. I apologize to anybody here who has any ties with DOT. But they have been doing a lot of pioneering work in setting the standards and driving them, pushing the needle forward in ensuring autonomous vehicles are coming to the market in a much safer and much more regulated fashion, much ahead than any other country in the world. So a lot of kudos to them. That said, the FCC has been our standard bearer in many ways. In fact, they have been known among the international regulatory agencies as the most aggressive spectrum regulator. Ofcom used to be in UK, used to be one of those, but the FCC is recently basically being more aggressive in terms of creating opportunities for additional spectrum use and making them available for cutting-edge services such as drones, autonomous vehicles and so on. So there have been a lot of spectrum reclassification activities that have happened over the last, I would say, 10 years. And many of you in this space would probably be aware of all the things that have been happening, most notably the more recent Spectrum Frontiers ruling that opened up upwards of 14 gigahertz of spectrum in the millimeter wave bands. And I think that's significant. A lot of us here wouldn't be talking about millimeter waves if it's not for the FCC pushing the opening of the gates there. And also, there have been, for those who are academics, it may be of particular interest that they have a new program called Campus Experimental Licenses, where you can apply for a large-scale campus license across a wide swath of spectrum, and which is significantly faster and easier than the current model, where you have to apply for each band, and you have to go ask the incumbent of each band for permission to use. FCC is making it much easier to just get a point-blank, large-scale allocation for licensing. So you should go look it up, and you can contact me if you want more information. So that's great stuff that they're doing. The NTIA, the National Telecom Informatics Administration, is the federal counterpart of FCC. The FCC is not a federal agency. They're an independent agency, right? But they do the answer to the customers. But NTIA is the government regulator on the other side, so they work hand in hand. Of course, the NTIA is essentially taking the brunt of the role in making federal spectrum available for sharing. So with this spectrum, essentially, is where the 3.5 gigahertz work, where the spectrum has been freed up, has come about. But that's largely due to NTIA's work. President Obama has tasked the NTIA with identifying 500 megahertz worth of spectrum by 2018 for advanced commercial sharing with commercial services, and they already have met that target. So there's a lot of policy work going on to make that a reality. So a lot of interesting work happening there. And of course, we all know that DoD has a huge interest in their own operational challenge, operational superiority issues that they want to ensure that they have a good handle of wireless communication issues. A lot of the pioneering work in mesh networks, ad hoc networks came out of the DoD, DARPA specifically. But more recently, in the last, I would say, last 7-8 years, they have been the precursor to a lot of the work that you are seeing right now, whether it's the mobile hotspots or the 100G programs or the radio map. So if you if you heard of Facebook's millimeter wave thing or the drone program that they've been running, they essentially recruited one of the performers of the DARPA mobile hotspots team. And that's essentially that's the new product that they're developing. So DARPA literally has been leading the way in that space. And their newest program is the Spectrum Collaboration Competition Challenge. They actually announced the competition, the proposal teams that will be funded through DARPA for that yesterday. So there are 4 academic teams that made it out of the 6 that were selected for that, which is great news for us academics because, NSF feels proud because we have funded many of these people and they are going on to, they will be hopefully proving their mettle in the collaboration challenge. And that essentially will lead to greater ways of sharing spectrum in a collaborative fashion without looking for specific policy regulatory guidelines. So that's an interesting thing to keep an eye on. And of course, there's a National Information and Standards Technology. So they've been doing a lot of work in channel modeling aspects of millimeter wave. And they've also have been talking to a lot of industries, companies, in creating what we call the future wireless technology roadmap. So that they will be publishing this by December, and hopefully that's going to lead to kind of give you a roadmap of what are the big challenges over the next 5 years to 7 years that as researchers we might be wanting to solve. Again, this is being produced in consultants with industry. They also have a public safety communications research program. Now, this is a relatively new program. So this was started with $300 million in spectrum auction funds, and the team got staffed only this year. So as part of that, they're going to allocate about $100 million in research for, just like the NSF spends money on external academic researchers, they are looking for proposals from academic folks in the public safety communications research spectrum area. Now, any of you who submitted proposal to NSF, stay tuned to this one because this is going to be much, much similar type of solicitation. So stay tuned. So that said, let me move on to my main role, which is NSF, right? So we do have a broad array of programs that go from systems down to theory, devices, and also things like what the V2X, the communication, connected vehicles, things called about cyber physical systems. So we have a lot of programs, and we also have several cross-cutting programs. One of them very specifically tuned to a wireless spectrum, which is the newest one on the block, is the spectrum efficiency, energy efficiency, and security program. So this is a cross program between engineering and computer science. So cumulatively speaking, right, we just between these programs we support more than $75 million a year in wireless research, and this does not include the funding we allocate for infrastructure programs and so on to build up labs and other things. So and we take pride in the fact that not only we promote cutting edge research, but we also train the people who end up going on to become part of companies such as Samsung, AT&T, NXP, NI, and so on. So these are the people who who are getting trained by NSF grants. I'm sure most of the engineers here and industry folks here have had some kind of a training through NSF-funded grant when they were in grad school. So this is one of our big missions. Okay, so and this is why I'm emphasizing this. This will tie down to what I'm going to wrap up my my talk with. So just keep this in mind. Now, our emphasis in wireless technologies essentially is in where we see as Greenfield Wireless. So a lot of the wireless design choices we have seen over the past 20, 30, 40 years have been hobbled by either regulatory policies or by the lack of availability of hardware or the sequence by which these things happen. And therefore, you as a researcher getting into a space, you really didn't have the freedom to do a lot of things. Now, millimeter wave, on the other hand, is going to change all of this. Essentially, we are facing a world where spectrum is being opened up, hardware development is going at a critical pace, and we have academics and industry keenly looking at this problem at the same time. So we are going to have a much more optimized and concerted effort to get things right. right? So we see, at least personally, right, I hate the whole notion of how spectrum is allocated, and those are artificial barriers in my view. And I see this as an opportunity to demonstrate, to everyone that if done correctly, spectrum can, there's a lot of spectrum available and you can solve a lot of our bandwidth problems, okay? So that's the very interesting avenue for us. And we believe that we have been ramping up our investments over the last 4 years. We have been matching a lot of the work that industry is doing. And of course, many of you know the work done both here and at NYU and many other places where they have already been producing very interesting results that industry is taking notice of. So this is something that we will continue to prioritize going forward. Now, that said, there are many other areas of wireless where we think there is greater contributions to be made. Dynamic spectrum, network management, large-scale cellular network design, making network access more affordable. So there are many different interesting places, given that everything is wireless now, right? Nobody uses wired Ethernet jacks anymore, except when you're in the lab, for example, when you're in a talk. But in order to do that, right, one of the fundamental challenges that we see and we have been looking at for the last few years is a lack of quality testing platforms at scale. So we all test things at lab, and then from there, to make it bigger, it's like I try it on a few users, and I have my 2 devices sitting on the table, it works great. When somebody starts moving around, goes around the corner, goes off, right? How do I test things at scale? So as part of that, so we announced this large-scale advanced wireless research initiative to speed up the innovation in academia, where they want to take things from lab to practice at a much faster rate. So this is a $400 million investment that has 2 parts. One is a $100 million investment into building 4 large-scale testing platforms. This is called the Platforms for Advanced Wireless Research. And this, out of the 100 million, 50 million is from NSF and 50 million is from industry. Many of the companies here are members of this consortium. So you can go to advancedwireless.org to look up more. And on top of that, there's $350 million over the next 7 years in research that will be done on top of these platforms once these platforms are deployed. So again, I can give you more. I'm just going through them really quick. And another challenge, like I said, we are worried about affordability of broadband and the ability for communication networks to operate when infrastructure is gone, right? For example, after an earthquake, after a hurricane. So we have announced 2 $1 million price challenges. So one dealing with the setting up critical communication networks after an emergency knocks out infrastructure. And another one about bringing low-cost broadband, not rural, but broadband access in an urban environment. So these are 2 challenges. Mozilla Foundation is going to help us run these challenges. Stay tuned to announcements from them starting November. Okay. Again, this is going to be open to anyone. So if you are a wireless network person who has done any kind of work building things, you would really want to see this, because this is something that you guys can play in very easily. All right, so we also have what I call as taking the next generation internet architecture all the way to the end user and the IoT device ecosystem. So this is what Intel is interested in. Intel and NSF have been partnering to put this solicitation out on the street. Solicitations, the proposal are due soon. This is what we call information-centric networking for the wireless edge, right? So we're talking about large-scale, low-latency communications for this IoT millions and billions of device ecosystem. So, of course, we have a US-Finland solicitation. And I also want to give a shout-out to a research coordination network on millimeter wave research. Again, to emphasize, this is a place where a lot of people are coming together at the same time. So we don't want to drop the ball and make sure that everybody is coordinated, and we're going to work together as a group. So University of Wisconsin is leading this effort, and many members from WCNG are actually part of this RCN as well. So we are going to have twice-a-year meetings that are going to get people together and discussing state-of-the-art research and so on. So, and of course, NSF is also partnering with DARPA on supporting academic teams to participate in the Spectrum Collaboration Challenge. So these are different initiatives that we are doing. And as far as we are concerned, our goal essentially is to help large-scale testing. And this large-scale testing is something that we want to be others to be able to verify. So why we are going with this kind of testing? We have seen where people demonstrate a result, but nobody else can replicate the result because they don't have the hardware, they don't have the code, they don't have anything. So what we want to enable with these platforms is you'll be able to specify an experiment, run the experiment there, and leave the experiment there for others to replicate, right? So people can verify that, yes, you have not missed something obvious, you have not made any mistakes, or of course, clearly you're not faking it, right? So we really want to do it. So that's something that NSF views this as critical to the progress of science in general, and of course, for me, wireless networking in particular, right? So we are actually going to make some few announcements in the next couple of months, specifically broadening the scope of this kind of reproducible research. We're going to call for proposals that explore the limits of technical breakthroughs. So you may have heard something about localization. Somebody claiming something, whoa, insanely cool, right? And then, of course, nothing else, because there's probably not a journal paper, you don't get the data sets. We would like somebody else to take the challenge of saying, I want to replicate this. I want to see under what conditions I can make this work, under what conditions I won't make this work, it won't work. And I'm going to publish the results for everybody to see. And NSF wants to support this kind of activity. So we essentially want to start characterizing breakthrough results, because if people don't trust the results, they're not going to be able to build on it. And that's our goal with this one. So again, stay tuned. We are going to see announcements very soon. Okay. Now looking ahead, it's all about spectrum, right? And of course, why spectrum? Because spectrum choice drives architectural design, radios, theory, protocols, algorithms, and then the applications, architectures and applications running on top. So given the huge amount of interest in everything is wireless, right? Wireless is the access that we have right now. We believe that this is where we want to go, and therefore open platforms, data, and so on. So again, I believe that the exciting times in wireless research, and it's going to enable a significant amount of societal change, which we already see hints of. Now, that said, okay, we got to be very careful. Okay, so I'll tell you why. Let's take automated vehicles, okay? Fleet driving is already a reality, all right? There have been studies, BMW has shown large numbers of 100 trucks driving on the Autobahn in Germany over 350 miles. And we have an operator running, what do you call it, not even fleet, like a single automated truck going around in Nevada, like multiple trucks of that nature. They are actually running right now, and they don't need drivers. They seem to work perfectly fine. And bulk of the trucking is done on highways, carrying stuff between highways. So as you can imagine, with less than a decade, 3.5 million people are going to be out of work. And extending that to the service drivers and other kinds of drivers, just this sector alone can potentially put out more than 5 million people out of work within 10 years. And that's 4% of the US workforce right now. And that's just one sector, okay? Now, robotics is going to accelerate automation in many service industries. And that's a huge amount of social change that's going to happen in a very short amount of time. Now, remember, the internet and everything that we know of is less than 20 years old. I mean, I remember when I was growing up in high school, things were much, much different, significantly different. And many of you may not be tuned to what's going on in the presidential election right now, but many of the frustrations that you see, right, without taking sides, you can definitely empathize with the frustrations that people feel because of this technological change. They may be blaming the wrong agents, but there is frustration. Again, that's acknowledged by everybody across the political spectrum. And we have not seen the acceleration yet. This is nothing. This is compared to what automation is going to bring in the next 10 to 20 years. So we do not want to be castigated as the villains, as the people who made this happen. Right? Robert Oppenheimer regretted creating the atomic bomb. Right? We don't want to be seen or regretting us and making it our future generations unemployable or creating a social unrest. So we want to be smart as scientists. We want to look ahead and engage with sociologists and other people who are expertise in this space. Look at what kind of disruptions are going to come. What are the ways in which this can be mitigated, if there are any? And I'm not saying we should get into policy, but at least we should be prepared to think of what's coming down the future, predict it much more accurately with a human in the loop. Pay attention to human considerations. Okay. Now, with that said, let me wrap it up by saying that one of the bigger challenges that is reflected in this sector is the fact that our workforce does not reflect how our society is today. Right? It's largely white male. At least within engineering and computer science, is largely white male, Asian, whether it's East Asian or South Asian. And that is going to, I mean, there's already a lot of awareness, for example, Silicon Valley has been trying a lot, but it's, we need much more concerted effort, right? And I believe that researchers at universities must work together much harder in their own longer-term self-interest. Now, you're not trying to do anybody else good. It's like, if society turns on you, you are going to be bearing the brunt of it, right? So we want to make sure that we are ready to work through us together. And NSF has a lot of interesting things coming up on broadening participation. This is our national priority, and the President has made it a point to address this in the last 2 State of the Union addresses. So I would beseech all of you to work together and make this, prepare to this, the exciting times ahead in a much more inclusive fashion. So that said, I'm going to happy to take questions.
I'm afraid we won't have time for questions, but I do want to recommend Thyag for President of the United States this this election season. I thought that was a wonderfully impassioned plea for social responsibility as we move toward an upheaval that we haven't seen since the Industrial Revolution. If you have questions for him, please catch him in the corridors. We've got to move on now to, thanks again, Thyag, to the Startup Showcase, and I'm thrilled to introduce to you Kathleen Byron.